So I thought for a change we should talk about human. We talked a lot about devices and machine learning this morning until now. But in this whole equation, there is a very important element, that's us. And this talk is about how human actually contributes to this loop. We heard a lot this morning from varieties of speakers talking about instrumenting machines, devices, cities, road infrastructures. We're also instrumenting humans these days. Maybe not implanting them yet, but we are still carrying multiple mobile devices, wearable devices. And these devices, when they operate with collaboration with nearby IoT devices, they create a completely new ecosystem for us to build brand new sensor systems. So what actually is happening, these on-body and near-body devices are creating opportunities for us to understand ourselves in a completely new way that was never possible before. And this is done purely through the sensing and the processing that we talked whole this morning. So I want to talk about this part of it. I want to talk about this behavioral aspect of this IoT, or sort of like this instrumented human era, and what are the challenges that we need to look at from a system design point of view that could manifest into these principles. So when we talk about instrumenting human, primarily we talk about health. We talk about plenty of health analytics, predictive analytics, primarily to offer people an insight of their everyday life and how they could live better, happier, and so on. But there are plenty others applications where this kind of on-body and near-body devices could actually offer remarkable benefits. Here are a few, which we already use on a daily basis, in some cases maybe on a weekly basis. So we talked a lot about conversational agents. Lucy was showing some super insightful numbers. Of course, these assistants are still pretty much sort of like a dialogue system, but they're increasingly becoming more contextual, fully aware of your social, environmental context, and sort of like adapting their behavior to meet your needs. We heard a lot from Feng this morning about the smart fridges and all these kind of products that try to understand your diet and your drinking habits. Hopefully they will actually help you to be in shape, offering you more effective recommendation for your food habits and so on. When you look into the industrial space, we see that increasingly we are using on-body and near-body devices to offer safety and adherence, guidance at real time, so that people can perform their task at hand more accurately. What type of experience are coming is actually mind-blowing. What you will see in the next maybe 24 to 48 months time frame, we will have technologies that will work in concert in your body and near your body that will help you to communicate better. So a lot of people actually have communication barrier. If you look into people with the dementia or autism, as well as just regular human, you are often nervous, you don't know how to interact and communicate at a certain situation. Technology will help you there. Attention or engagement is one of the most fundamental resource that we strive for, because the difference between a successful individual and a regular individual is they can concentrate better than you are. So why don't you think this instrumented world that is around us can actually understand and monitor when you are attentive, how it was, and why that cannot be recreated to make you focus better every single time. And this is going to happen very soon. Sleep is a fundamental part of our life, and as we grow older, it's become sort of like your one of the main activities to keep you healthy and sort of like your neural functions to operate in a nice way. Technology will help you soon, instrumented ones, to sleep better by understanding your sleep, but knowing how you sleep, what type of environment makes you sleep better, so that you can actually experience a good sleep all the time, and that will help your cognitive function and so on. memory augmentation. It's an incredibly powerful application area. Many of you are wearing glasses today. The reason is that you have problems with your eyes. You go to a doctor and they recommend you a glass. Similarly, if you have a problem with hearing, you go to your doctors and they give you a hearing aid. Have you ever wondered, you have problems with the memory, why you don't get an aid today? Why don't technology can help you? Actually, technology can. So today, I think it was Nick who was showing you that the technology that Microsoft developed to offer you sort of like a caption of what you're looking at, right? So if you think about live logging technology using sensory channels like vision and audio, you could create a complete memory, digital memory of your everyday life, and that digital memory can be accessed any time in the future to support your task at hand and your interaction at hand. Now 47.5 million people only in the UK are suffering from dementia, costing a staggering £26 billion every year. So why can't we build a technology for helping people with memory issues, right? So, and it's going to happen very soon because we are actually getting there. So these examples I just gave you is essentially posing one single question, and that is that we need to build technologies today that can help us to understand us and the world around us in a better way. And if you can do this, all these experiences I was talking about will be very easy to realize. Now, I call this type of user experience behavioral user experience. The reason being that for long we've been building systems and user experience typically as like taking input implicitly, but what we are increasingly seeing is because of the sensing capabilities we are having around us, the input of the system will be primarily driven by your behavior, and this behavioral user experience has three fundamental properties. Typically they require cross-device interactions because you're you're interacting between devices and you're moving from one environment to other environment all the time. Typically, these interactions across space and time, so you have to carry over your user experiences, and also these experiences would require you to be very personalized because everybody will have their different way of interacting with the system. So in the next few slides, I want to talk about a few systems that we have developed over the last few years in the labs, where we try to create this sort of like experiences by instrumenting people, things, and places, and by quantifying their interaction. So basically, when humans interact with other humans, so places and things, what we can learn and how that learning could be used as a manifestation for the system experience. So the first project I want to highlight is called a Quantified Enterprise, and this was really about understanding how people work in a work environment and how they interact with the places and the things and other peoples, and whether you could actually provide them a meaningful feedback that would help them to become a more productive and individual at the workplaces. Why we're looking at the workplaces? Because this is just some numbers. That we expect that this would be a $55 billion industry by 2022, and we expect that there will be remarkable growth in this market from all these market projection studies. So essentially, what we try to do there, that we put a lot of instrumented sensors in the environment that were collectively understanding people's interaction with each other, people's interaction with the different places and the rooms, and then creating a sort of like a map of how people use the space, how people interact with other, how people move from one places to other places, where the interaction happens, how long they actually do the interaction, and so on, and that collectively provide us a very crystal picture about what happens in the workplace from building analytics point of view as well as from the people analytics point of view. And this has quite a number of interesting implications. From a building analytics point of view, you can think about, you could actually organize your resources completely new way because you have a complete awareness of how the building is used, how the space is used. From a user interaction point of view, this is also interesting because often you are completely oblivious about your workplace behaviors, workplace activities. So once you have a little bit more understanding, you could certainly provide very meaningful changes in your life. These are heavily published works in UbiComp and in other events. Of course, I know a lot of people, when I present this work, ask about privacy and so on. So we have studied a lot about the implication of privacy in this kind of settings, using this kind of technologies, and how people react to that. And actually, it's not necessarily bad. So people has actually reported to be very excited about these technologies once designed in a more privacy-preserving manner in the right way. Then we go one step further, is not just understanding the interaction with other people and things and so on, but we also wanted to provide people a sort of like a well-being management and cognitive augmentation capability in the workplaces. Some of you are familiar with this Wearable platform that we have developed and shared with many of the academic colleagues of ours. This has a bunch of sensors. So we tried to actually use this sensor to understand people's physical, social, mental and activities, and then sort of like provide them a collective feedback of how it is going on the recommendation form. Like for example, you get to see that, you know, like how you were feeling at a particular meeting when you were surrounded by some people, and whether, you know, this sort of things could actually help you to reflect your behavior better and so on. All these things are done locally, so nothing is in the cloud. So it remains on the device, remains on your personal space. Data is owned by you, so whenever you want, you can delete these things and so on. So it's basically purely a personal scale sensing, where the data remains on your mobile devices, where all the processing are done. But what this kind of application is actually reflecting is that the first application was really about interacting with the spaces, and this one is actually interacting with yourself. So you actually have a better reflection of how you spend time and so on. The next application is actually pretty interesting one. So we take technology outside and we give it to the postmans. So why postmans? So we wanted to use the postman as a human sensor for gathering country scale data. Often, you know, like when you collect data for sort of like a smart city, we heard earlier in the lunch, before lunch, the smart city projects and so on. One of the fundamental problem of collecting subjective data in a smart city scale is we don't have effective sensing infrastructure for that. It's expensive and so on. So often we use crowdsourcing, but that doesn't scale because of the coverage problem, either spatially or temporally, the accuracy problem, the sustainability problem, and so on. So in this particular project, what we did was that we basically went to the Belgian postal network and we tell them, hey guys, you guys are dying anyway, so why don't you come and work with us? We'll provide you new revenue opportunities. So what we really do here is that we instrument the postmans with the capability that they could actually sense the environment, and at the same time they could do subjective data collection. So when they're delivering a package, they could actually ask the individual how you're feeling, what do you think about the road safety, do you think you know, like your neighborhood is safe, all these things. So it's basically, you know, like you get a label good quality data that can quantify the data that they were collecting with their mobile devices or wearable devices. We also wanted to make sure that we do not interrupt their primary task. So the sensing here is used is actually the first example in the world where you use wearable for a large workforces in a practical manner, where we use the watches to actually understand their physical, their location, physical activity, the location activity, and the conversational activity, and we combine these three pieces of information to identify the most opportune moments when they could actually ask such question without interrupting their primary task at hand. So the last example is a very recent work where we tried to actually look into what is the current problem of these conversational agents that, you know, Lucy was talking just 10 minutes ago, that 60% of the voice search by 2020 would be done by voice. Now, you know that the Siri, Alexa, Cortana, Hey Google, whatever you ask, they are completely oblivious to your emotional state of mind. And often when you interact with another human, they often actually know how you're feeling, what your social situation is, and typically people adapt based on that. Unfortunately, these agents do not have that capability. So we thought, okay, since we can actually do the sensing and the behavioral understanding of you know, how you are and how you feel, if we feed that information to the agent, maybe the agent can actually adapt themselves better and provide you some interesting experience with them. So all these different 5 use cases that I showed you here, all these are heavily published work. I didn't want to go all the technical details, but my team and I'm here would be love to talk about all these different technical challenges that we actually had to face and solve the problems. So we, you know, we can build these things. Now, In the next few minutes, I want to talk a little bit about the future. So I wanted to say that what it is going to be when you bring human in the loop, what sort of systems, challenges we need to deal with, and so on. So I bet on that in the future we will build devices and the sensing systems that will typically be multi-device, multimodal, and personal. And this is interesting. The reason it is interesting is that today machine learning is primarily looking into single device, single modality modeling. Okay, multimodality is coming, but not multi-device is coming. Now, collecting real-world sensor data, collecting from multiple devices is twice or maybe 3 times more expensive than collecting from a single device. But if you want to really create a good user experience coming from this kind of IoT and the on-body devices, you need to deal with that. So there are a few other challenges that collectively in my team we are looking at, the challenges of fusion or selection problem, the challenges of robustness problem when it comes to multiple devices. We typically talk about single device, but when you talk about multiple devices, we're in a completely different ball game. Continual learning and online learning is another important part because, again, our changing all the application I showed, it's sort of like a continual application, so your behavior will change over time, even over a week, and system need to adapt to that. How do you do with this? And I don't want to talk about efficiency because we heard a lot about efficiency whole morning, so I thought maybe I leave it to those to others. Now, 6 challenges I want to tell you now. These are very much user-centered challenges. I know this is MobiSys, this is system design conferences, but folks, you need to understand this. If you build systems for human without talking to human, your system will never be used. Okay? So, challenge number 1, don't build models without talking to your users. So I give you an example, right? So a couple of years ago, Google released this camera called Clip, which is sort of like a memorability camera that it will understand your memorable moments. Now you tell me, how do you model memorability in your vision models? What does memorability entails, right? Similarly, when you talk about this virtual reality glasses, these days, rendering engine often need to take care how people are feeling in terms of their comfort level. It's very difficult to model those kind of literals. But it's absolutely important that you, as system developers or model designers, try to take into account the learning objectives that will be driven by user needs. Okay, so this is really, really important that your learning targets does not just become what is easy and easy to collect or easy to do in your studies. You have to understand what is the application needs are, and based on that you have to come to your learning needs. So I mentioned a bit ago that what typically happens today is that we design a model once and then we hope the model will operate well all the time until I release my next version of the model. But typically what happens is that even the same user will use your system differently tomorrow or the day after tomorrow. So the learning needs to adapt with this changing behavior that happens during the day, during the week, during the month, and so on. So you cannot make a very static model. Your model needs to adapt with this kind of varying condition. Number 3 is, Lucy mentioned the ugly of AI is that we don't understand AI. Now, the problem is that when you build learning-based systems, you often do not know what the system will do when the system fails, right? If the last couple of months ago, I was at IPSN and we had an interesting panel where the questions were being asked that what happens when we build a system with 99% certainty. Well, it's fine if it's turning on your TV or turning on your, lights. But if it's your airplane taking you from Seoul to your home back and there's a 99% chance that it will land, that's not very safe. The same thing is that in the industrial cases, if you're saying that I'm going to make everything automated by applying AI, but there are 99% certainty that it might work and and the may not work, it will not be there. So traditional mission critical system from a software verification point of view are absolutely important to embed this kind of principles, but then we don't know today what we should do when the system fails. So you need to incorporate human in the loop, perhaps in some form, so that this can be shaped. If the system fails, people take over, right? Again, another problem is the problem with intelligibility, and I'm not talking about explainability. Explainability is how the model works, but this is more about from a user point of view. One, you actually deploy the model, you need to tell what your system is doing. So if the system fails, and I give you an example, I use Amazon Alexa pretty a lot in my home. So it's not it's not necessarily a surprise that I have tried to connect all these things. So what happens is that if I want to turn on my light, which is basically plugged in into a TP-Link switch, and I ask Alexa to turn on the switch, often Alexa does not know, or I cannot connect. But it does not tell me where the communication is broken. Is it the communication between Alexa to my home router, or home router to the Amazon cloud, or Amazon cloud to the TP-Link cloud, TP-Link cloud to the device? Where it is broken? Tell me what I can do. I have absolutely no answer, right? So I keep trying and keep trying and keep trying until I'm frustrated and turn on by myself. That was a very simple example for my turning on the light, but it's really important that you give user the feedback where your system is failing and what you can do about it, right? Two other challenges, very system level challenges. We talked a lot, so I'm not going to focus on this. One is this robustness, because when you talk about multi-device, multi-modal cases, you need to make sure that once you switch your devices, switch your environment, switch your operating system, your model still performs. Often it is not today. Again, if you want to know, talk to me later. I will provide you more background on this. And again, efficiency is a key area. We heard a lot. I'm not going to talk about it. I think it's well understood that that's one of the key area of focus that the community as a whole needs to look at it. Before I conclude, I want to draw your attention to this Friday. We have the Wearable Systems workshop. Some of you have already registered to join in, but please do register because we have some exciting speaker. So Steve Mann, who is the father of wearable computing, is coming to give us a talk, and apparently he's going to show us a demo that nobody has seen before. So you're welcome. And we are hiring throughout Bell Labs across the world. So if you are interested, come and talk to me. Thank you very much.